In this video, we will look at how to simplify algebraic expressions. So the first thing we have to look at is how to collect like terms. So first off, when you're given an expression like ABC with no brackets, we need to bring all of our like terms together. And what I mean by that is any term that has the same variable and exponent combination. So if we look at this first example, 4x, 5x, and 2x are all like terms. Now, something that is super important is that the sign that is in front of the term stays with the term. So when I am going to move things around, the sign will come with it. Now, in the same example, -7 and -3 are also like terms. So first thing, I'm going to rearrange this and put all of the x's together. So I have positive 4x, positive 5x, positive 2x. And then for my constants, I have -7 and -3. The sign came with it. And now at this point, you would just do the addition or subtraction. So for my x's, I'm going to do 4 plus 5 is 9, plus 2 is 11. So I have 11 x's in total. Notice that the x did not change. It did not become x cubed because you saw 3 x's. The variable stays the same. And then for the constants, I am not doing 7 minus 3. I am doing -7 minus 3 because the sign goes with it. -7 minus 3 is -10. You're adding the negativity. So let's try another one. In B, I have 3x, -2x, and positive 8x. And then the other set is the 5 and the 10, both positive. So I will rearrange. So the 3x, -2x, the negative came with it, and positive 8x. For my constants, they're both positive, so nothing special. And now I simplify the coefficients. So 3 minus 2 is 1. 1 plus 8 is 9. I have 9 x's in total. And then 5 plus 10 is positive 15. In our final collecting like terms example, I did bring in another type of like term. I have those x squared terms. So in this example, the x squares go together, the x's go together, and the constants go together. So the 2x squared is like 4x squared. The -4x would go with the -5x because they both have x's. And finally, the constants go together. So the 8 and the -1. Now at this point, I want you to try to pause the video here and rearrange this expression so that the x squares go together, the x's, then the constants, and try to simplify it yourself. Once you're done, come back to the video and see if you did it correctly. All right, so we should have 2x squared plus 4x squared, -4x minus 5x, check your signs there, and positive 8 minus 1. And now when you simplify, we have 2 plus 4, so 6x squares in total, -4 minus 5, so -9x. If you did 4 minus 5 and wrote -x, that would be wrong. The sign belongs to that 4. And finally, positive 8 minus 1 is positive 7. And that's it for collecting like terms. Now we're going to extend this and bring in some brackets. So when we do have brackets in our algebraic expression, we have to remove them. And the way that we remove them is by doing distributive property. So you'll notice in all of these 4 little examples here, I have a term in front of my bracket. Now I'm going to go to the side here and show you the generic distributive property. So if I have A times B plus C, if I want to remove those brackets, I'm going to take A, the term in front of the bracket, and just multiply it by however many terms I have inside the bracket. So I would do A times B, and then plus, because that's the sign, a times c. And that's it. You just bring in that term outside the bracket through multiplication. So we do have to remember our multiplication rules. So we will multiply the coefficients together. And then if we have variables that we have to multiply, it will affect the exponent. And we'll see that in a second. So let's get started. 2 times x minus 5. So I'm going to take the 2 and do 2 times x. 2 times x is just 2x. And then 2 times, not 5, 2 times negative 5. And that's negative 10. And then this one is done because there are no like terms for us to collect. Let's try the next one. I have 3b as my term outside the bracket, as my monomial. So I will have to really think about the variables here. So when I do 3b times b, first of all, the coefficient in front of that b is just a 1. So technically I'm doing 3 times 1 is 3. Then when I multiply the b with the b, the exponent will change. I have to figure out how many variables do I have. I have 2 b's, so I'm going to write b squared. Now, when we were collecting like terms, we never changed our exponent because we were doing addition. But here we are multiplying. When you multiply variables, the exponent will change. And finally, 3b times 2. 3 times 2 is 6, and the b just stays there. Let's try another. Now with c, you have to be very careful because our monomial is negative. So I do have negative 2m that I'm multiplying in. So I do have to think about that negative and be very careful with it. So I'm going to do negative 2m times 3m squared. So let's break it down. Negative 2 times 3 is negative 6. And then m times m squared. I have 1m in the first term, 2m's in the other. That's 3 in total. So negative 6m cubed. And then again, negative 2m times negative 4m. So negative times negative is positive. And then 2 times 4 is 8. And then m times m, that's 2m's in total, so m squared. And finally, negative 2m times 1. Anything times 1 is itself. But also, if I did negative 2 times 1, it's negative 2, and then the m just stays there. So let's go to our last one before we combine everything. So I want you to pause the video here and try distributing this 5x squared into that bracket, and then come back to the video to check your work. All right, so when we do our multiplication here, 5x squared times 2x, 5 times 2 is 10, x squared times x, that's 3x's in total. Then 5 times negative 4 is negative 20, x squared times x squared, 2 and 2, that's 4x's in total. And finally, 5x squared times 3, 5 times 3 is 15, and the x squared just stays there. Now, normally we would be done, but I did mix up the bracket a little bit. You'll notice that the higher exponent is in the middle, which kind of messes up your final answer. Now, a little communication thing here is that whatever your higher exponent is, it has to be at the very front. So pretty much your terms have to be written from highest exponent to lowest. So I am going to take this negative 20x to the 4 and bring it out in front just to make it proper form. So your actual final answer for good communication is negative 20x to the 4 plus 10x cubed, because the number was positive, and then plus 15x squared. And that's it for distributive property. So now we're going to take collecting like terms and distributive property, combine them to simplify more complex algebraic expressions like these ones. All right, so to combine everything, first thing is always get rid of your brackets. So we're going to do a distribution with the 2 to bring it into our first bracket. So we have 2 times x is 2x, 2 times negative 4 is negative 8. Then we're going to take the positive 3x and we're going to distribute it into our second bracket to remove those brackets. So 3x times 2, 3 times 2 is 6, x times x is x squared. And then 3x times 5, 3 times 5 is 15, and the x just stays there. Now at this point, you're going to notice that we do have some like terms, not many, but the 2x and the positive 15x are like terms, so that we do have to collect them. The 6x squared has no other x squared, the constant has no other constant, but I am going to rearrange this to put the highest exponent first. So here's my 6x squared. Now I'm going to group my x's and the constant at the end. And now I can just collect those middle two terms. 2 plus 15 is 17, so I have 17 x's in total. Notice again, when I collected like terms, the x did not change, just the coefficient. It was only when I multiplied that exponent came in. Okay, let's try the next one. I'm bringing the 3 into my bracket. 3 times 3 is 9, and the y stays. Then 3 times negative 5 is negative 15. Now in the next bracket, we have to be very careful because we're not distributing a 2n, we're distributing a negative 2n. So negative 2 times 5 is negative 10. But negative 2 times negative 3y is going to be a positive number. 2 times 3 is 6, and the y stays. And now time to collect. So the y's go together, and then the constants go together, noticing that both constants are negative and the sign will move with it. So I have 9y plus 6y, and then negative 15 and negative 10. So when I collect these, 9 plus 6 is 15, so 15 y's in total, and then negative 15 minus 10. So if you are using your calculator, make sure you are putting that negative in there so that you get negative 25. If you just write 15 minus 10, you're going to think that the answer is 5 and write minus 5, which is completely wrong. So be super careful with your signs. All right, for the next one, how about you pause your video and try this on your own? Bring the m into the first bracket, bring the positive 2m into the second, then collect and simplify. Then come back to check your work. So when we multiply the m in, hopefully you have 4m squared, and then m times negative 3 is negative 3m. When I do 2m times m, that's 2m squared. 2m times negative 5 is negative 10m. Now in terms of collecting, we just have the m squares and the m's. Watch the signs. So when you rearrange, 4m squared plus 2m squared, but here's the potential mistake part, negative 3m and negative 10m. So when I collect, 4 plus 2 is 6, but for the m's, negative 3 minus 10 should be negative 13m. If you wrote negative 7m, you probably just did 3 minus 10 and then just put the sign in. So be careful. All right, for D, we have the 4x that needs to go in. 4 times 2 is 8. X times x is x squared. Then 4 times 10 is 40, and the x has no one to get multiplied with, so it just stays. Now this one, I want you to be very careful because in front of that second bracket, you have a negative. You need to distribute that fully. And that negative as a number is negative 1. So we have to multiply negative 1 into everything. And really what that's going to do is just change all of the signs. So negative 1 times 3x squared is negative 3x squared. Negative 1 times 10x is negative 10x. Negative 1 times negative 5 turns it positive. So look at all of the signs. They all swapped. The 3x squared used to be positive, now it's negative. The 10 used to be positive, now it's negative. The 5 used to be negative, now it's positive. And now we collect. So the 8x squared goes with the negative 3x squared. The 40x goes with the negative 10x, and the 5 just stays there. And now 8 subtract 3 is 5x squares. 40 subtract 10 is 30x, and the 5 is just there. Okay. So again, how about you pause the video, try E and F on your own, being very careful with the signs. Once you feel good about those, come back to check your work. Okay, so when the 2a goes in, you should have 2a squared subtract 12a. When the 5a goes into the trinomial, you should have 5a cubed minus 10a squared minus 5a. So really be careful with the exponents there. They all went up 1. When I collect, be careful here. I am going to put the cubed term first, then the a squared terms. Watch that I took the 10 with the negative, and then both of the a terms are negative, so be very careful there. So now the 5a cubed is on its own. For the a squares, we have 2 minus 10, which is negative 8 a squared, and then negative 12 minus 5 is negative 17a. For the next one, we were bringing 3p in, so 6p subtract 3p squared. And for the next bracket, I hope you are very careful with the negative, because we are distributing the negative 2 in. So negative 2 times 3p squared is negative 6p squared, and then negative 2 times negative 5 is positive 10p, and negative 2 times 7 is negative 14. Now, again, when I rearrange, I am going to be careful with the higher exponent first. So I'm putting my 2p squared terms first, then the p terms, these ones are both positive, and the constant at the end. And again, we're going to be careful with our signs. Negative 3 minus 5 is negative 9p squared. And then 6p plus 10p is 16p, and the 14 at the end. So it is very repetitive, but there is a lot of room for little mistakes with the signs or the exponents. Now the final 2 questions I have here are a little bit more challenging in that I have 3 sets of brackets, which means 3 extra times for silly little mistakes. So let's try the first one together, and I'll have you do H on your own to try it out. So here we have triple the distribution. So I'm going to distribute 3n in. 3n times n squared is 3n cubed. 3n times negative 4 is negative 12n. Then I'm going to take the 2n positive and multiply it in. 2n times 4n, 8, and then n squared because we had 2 n's, and 2n times 8 is 16n. Now for this last one, we have to be very careful. We do have a negative 1 that has to get distributed in. So negative 1 times 3n squared is negative 3n squared. But here is where there's potential for mistake. We have a negative 1 times 1, which is negative 1, not positive. Now we rearrange. So we have the n cubed, the n squares, the n's, and the little constant at the end. If color coding helps you, do it. So 3n cubed, positive 8n squared, negative 3n squared, negative 12n, positive 16n, and the negative 1. Notice again, the signs came with me. And now to finalize, 8 minus 3 is positive 5 for the n squares. Negative 12 plus 16 is positive 4 for the n, and the constant is there on its own. And now for the final one, pause it, try it, and then we will take it up. And just a little note, we do have a negative 1 in front of that second bracket. So pause and then return. All right, so I'm going to do h over here. So first we have the 3x coming in. So you should have 6x squared minus 15x. Then we have this negative 1 coming in, and really it just changes all of your signs. So negative 1 times 4x is negative 4x. Negative 1 times negative 1 is positive 1. And then finally multiply the x in to get 3x squared and 7x. And now just a quick rearranging. I don't have any x cubes, so I'll just put the x squares together. Then I have all 3 of those x's, so negative 15x, negative 4x, positive 7x, and then I have the single constant at the end. And now to collect. 6 plus 3, I have 9x squares, and then negative 5 minus 4 is negative 19, and when I add the 7, that's negative 12x's. And then the plus 1 at the end. And then that's it. So again, when you collect your like terms, be careful with your signs. When you're doing distribution, be careful with your exponents and your signs, and just be very careful in general.